Hi everyone, welcome back to News Chem Corner. In today's video, I've got you covered with chapter-wise checklist for the most important topics or tricky areas you must revise before the exam. Whether you are short on time or just want to make sure you haven't missed anything. So this video is your perfect last minute guide. Let's get started. So in chapter 1, as you know, atomic structures and properties, the very basic chapter, 7 to 9 percentage will be the weightage. I think except that acids and base and the unit 3, every other thing is the same weightage, 7 to 9 weightage. Okay. So in this chapter, the main points we need to study is first one, mole concept, right? So mole concept, the main point is, the all conversions are like 1 mole is equal to, if you need the particle number, you can relate with a 6.022 times 10 to the power of 23 particles. Correct? Okay. Then if you need the mass, then 1 mole is equal to molar mass. You can connect with the molar mass if you need the gram. If any conversion related to volume, you can connect 1 mole is equal to 22.4 liter at STP. Isn't it? So these are the mole concept main thing. By using this relationship, you can convert everything. Right? Okay. So the next point, empirical formula and molecular formula. For that, they will give some grams of some substance, like for example carbon. 5 gram of carbon is there and 10 gram of hydrogen is there, like that. So what are the steps? First one, the given gram or percentage. Sometimes they will give the percentage. So percentage or gram, don't need to change anything. The given percentage as such you can take and divided by the corresponding atomic weight. So carbon weight is 12, hydrogen weight is 10 over. Don't want to consider like the atomic, just single hydrogen. So 1. Okay, so that you got the relative number of moles. So then the number of moles divided by smallest n. Among this one, which one is smaller? Okay, smallest n you can you can divide with the smallest n, right? That will be the empirical formula. Suppose you got this one as 2 and this one is 1, which means C2H will be the empirical formula, right? After that, you can connect with the molar mass, molar molecular formula. If you need molecular formula, what you need to do, they will provide the molecular mass. So what is the molecular mass? They will give molecular mass divided by the empirical formula mass. So what is empirical formula mass? Suppose you got a C2H2 here, then the empirical formula mass will be 2 times carbon weight, which is 12, plus hydrogen weight and number of hydrogen. So this will be the empirical formula mass, and they will provide the molecular mass. Okay, so when you divide this one, you will get a number. So that number I'm just telling like X. Then your molecular formula will be C2X and HX. Okay, in that way you can calculate the molecular formula. Clear? Right. Then after that, sometimes they will give, instead of this direct gram, they may given with a combustion data, combustion analysis. At that time, what you need to do is grams of carbon dioxide, you can convert it to grams of, like 44 gram is CO2 is 1 mole. Then 1 mole of CO2 contain, yes, 1 carbon. So 1 carbon is 12 gram. Like that you can convert to the grams of carbon, right? After that, grams of water also they will provide. So you can similarly convert it to grams of hydrogen. And the compound mass, maybe 10 gram of compound is you are taking. So at that time, and the compound is not only but carbon, hydrogen, usually carbon, hydrogen and oxygen is also be there. Like CS, HY, OZ will be the form. At that time, you can convert the grams of oxygen by using 10 gram minus this grams of C and minus grams of hydrogen. In that way, you can get the grams of oxygen. After that, you have to do the same step, like given gram divided by atomic mass, corresponding atomic mass, and then n divided by smallest n. So that will give the empirical formula. Okay. So that will be the thing we need to do with the combustion analysis. Okay. Then after that, normal stoichiometry. Normal stoichiometry you need to do, and gas stoichiometry is there, solution stoichiometry is there. As you know, gas stoichiometry is PV is equal to nRT. We will do with the chapter 3 also. And solution stoichiometry, like M is equal to molarity is equal to N over volume. Volume of solution in liter. right? By using this equation, you can easily calculate the number of moles. So you can convert to number of moles and the corresponding mass. Okay. And then the main important point is in this chapter is mass spectrum. Okay, so mass spectrum is like, see, this is the mass spectrum. And see, a mass spectrum question be like this. They will give a mass spectrum like, isotope have different mass. So they will give the different mass spectrum. And see the height. Height will indicate the natural abundance, right? Higher height means higher the height of this peak, which means higher will be the natural abundance, isn't it? Okay. So in this figure, see the question, how many neutron does most common isotope of chlorine have? So they were given, this is ClO minus isotope. ClO minus isotope, in which oxygen is stable isotope, which have only 16 molar IMU. Okay. So chlorine, oxygen is 51, correct? So in which oxygen is already 16 and both of them it's stable. So this is 16. So the mass of chlorine you can do by 51 minus 16, right? And here also 51 minus 16. But what they need, the first question, how many neutrons does the most common isotope? So most common isotope means, this is the only thing we need to consider. You don't need to consider this one because this is having highest height. So what will be the thing? Chlorine atomic number, it's 17. So you have to just subtract the 17 also from this one. Correct? In that way, you can calculate the how many neutrons. So that kind of mass spectrum questions you can expect. Okay? Right. Then the important point in this thing, photoelectric spectrum and electronic configuration. You should know with how to write the electronic configuration of ions, atoms. This is the PS. So what does it mean? Binding energy is in this way, right? This way it's increasing. And the first peak is higher binding energy means this is oneness curve. 1s2 and second peak is there. So this is also, this is 2s2 and this is 2p6 and this is 3s2 and what may be this one. Again, the height of the peak will determine how many electrons are there, right? So 3s2 is this many electrons, E2s2, 1s2 is all are this much of height. So this may be yes. After 3s2, this one may be 3p, but only with one electron. So you can easily identify 3p1 means which is the element. Yes, aluminum, right? So in that way, kind of questions you can expect. And the question be like which one having a highest velocity. Like when you are apply the electromagnetic radiation, which one will have a higher velocity, kinetic energy. So that will be for high valence electron, right? Or sometimes the question be like which one is having highest binding energy. So that is, or which one is hardest to remove the electron, remove from the atom. So that is 1s2. Okay, that kind of questions you can expect, right? Then the most important thing is periodic table and trends and also most common ions. Okay, so periodic table, as you know, this is the periodic table. You have to know which are the blocks and how do you write the electronic configuration and see their trend. As you know, left to right, atomic radius decreases, and others are increases. Okay, others means electronegativity and ionization energy mainly. Electronegativity and ionization energy increases. And the same thing, like top to bottom, atomic radius increases, the others are decreases. Ionization energy, electronegativity are decreases. That kind of knowledge is needed. And then, as you know, the trends like the charge. First group always they have a tendency to form +1 ion. Second group is +2. These things are not predictable, it's variable, right? And similarly, but even though transition elements are unpredictable, uh, silver, zinc, cadmium is obvious. So zinc and cadmium is +2 always and silver is +1. And see the group 13 usually +3. Group 14 is also it's unpredictable, like lead and tin. Lead and tin usually form +2 as well as +4, right? Okay. And similarly, group 15 -3, group 16 -2, group 17 -1, and these are 0. This is the trends of ionic charge. This much of things you need to know with the chapter 1.